Hello everyone, Gilman Lowy here. Today we're going to be playing the Universe Sandbox. This is a game where you can sort of do anything you want in space. I've had this game since about Christmas, and I just haven't been, or I just didn't make a video on it. So yeah, I think today we're going to be trying to terraform Mars. It's the most promising for terraforming and colonization since it has carbon dioxide in its ice caps. As you can see, there's a bit there too, and so it's also the best because it's the closest planet, and also Venus is way too hot for colonization since it has a greenhouse effect that has been going on for billions of years before today. And so Mars is a cold desert planet which has a really thin atmosphere. It's only 1% of Earth's atmosphere. Even though it contains mostly CO2, it's not enough to trigger a greenhouse effect. Now the best way to terraform Mars, or to warm it up, is to simply melt the ice caps, which is dry ice, which is frozen CO2. Now we can raise the planet's temperature to melt those caps by simply just guiding objects toward it, like, oh, I don't know, maybe Hades' comet, but you know, objects like probably from the asteroid belt, since there's so much objects there. I'm gonna have to go a bit closer here. And so we'd have to puddle Mars with as many objects as possible to make its temperature a little bit more habitable. Now, this game doesn't really simulate a greenhouse effect. So what will be happening is, as more heat is created by the impacts, the caps would melt, which would release all the carbon dioxide, and that would trigger a greenhouse effect, which would warm the planet. Now there's evidence that water had been on Mars about a few billion years ago, like 4 billion years ago. Even though the sun was less luminous, less heat coming off of it, it had an ocean, even a magnetic field, and then that shut down because it froze, the core froze, and that caused the atmosphere to be stripped away by the solar winds and stuff like that. And then we get the desert that is now Mars today. Now I'm sure that probably doesn't help much, so let's try some bigger objects. I'm gonna say maybe Sears. So all these objects, they probably form into a ring around the orbit of Mars, or just an orbit around Mars itself. And so we got some temperature gain. Now there's no way that someone could realistically do something like turn on the magnetic field like what I'm about to do. So Earth's, for reference, is 0.319. That's the strength of it. And so you can see here, now it's blocked from the solar winds and radiation from the sun. And so, yeah. We also have to increase the water content to about an ocean. So yeah, so we'd have to continue warming up Mars to melt the ice caps, and then put like water which comets towards so it hits it, and then we get a habitable planet. Or at least that's the concept. Now this would take probably hundreds of thousands of years, which kind of sucks, but you know. I'm gonna reset this. Now I'm gonna try and do it to Venus. So for Venus, the only real likely habitization of the planet is to have floating cities like from Star Wars in the upper atmosphere, because it's still toxic. You need the oxygen, but not much radiation would reach you since the atmosphere is so thick. Is there even a magnetic field on Venus? No, there isn't. I'm very surprised. 0.319. So, in order to possibly what's the word? Oh yeah, terraform Venus is to try to get rid of the atmosphere. And that's probably impossible in real life. Or very slow if it is possible. But where do I... Oh yes, atmosphere. So the pressure, of course, it is 93 times higher. So we're gonna have to put that to 1. Doesn't really change it. I'm sure in real life it would change a bit. Be much less thicker. Much less like a gassy planet. So of course, this planet is pretty, or I mean closer to the sun. But, yeah. But it would just be pretty warm compared to Earth. Oh, we'd have to speed up the rotation. That's a big one. Because that means the planet won't be balanced. Yeah. Okay. And also, this planet does rotate counterclockwise. The opposite of the Earth, basically. So, yeah, that would be kind of strange. Now let's fast forward this, see if anything changes. Yeah, that doesn't change. Real life changes would happen, but yeah. Alright, let's try something else. Let's see what happens when the moon impacts Earth. May not never happen. But if the moon suddenly loses all of its velocity... Oh wait, I can just add moon. If the moon loses all of its velocity, I discovered that it starts to head towards Earth thanks to gravity. So there's the moon. And so if we take the moon, we take its speed, make it 0, it starts to head towards Earth at an increasing rate of speed. Let's fast forward this a bit. So as it's heading towards Earth, of course the tides and everything about the moon that affects Earth will get stronger and stronger. Also the moon would get bigger. So from this angle we wouldn't see it until it's too late. And so it's getting super fast. So how fast is it traveling? Yeah, 5 kilometers per second. You can see there's a shadow going on right there. So I'm gonna go ahead and I'm gonna try and make it live time. That's close enough. So at this point, the moon would start kind of distorting the surface, especially where the ocean is. That would kind of be strange. So now entering the atmosphere, it starts to burn up in the atmosphere, creating up tons of heat. That would be simulated on here, but it doesn't do that on here. So yeah, about now it's entering the atmosphere, as you can see there. Once it makes first contact, the Earth will start to warm up like crazy, and everything, especially right here, yeah, that would probably all spontaneously combust. Yeah, as you can see, the temperature is going up rapidly. In real life, it might be much more intense. Let's check this out. Yes, as you can see here, everything's black because it's super cold compared to this. As you can see all the material starting to be ejected into space. So of course the moon is going to get destroyed. Well, obviously, because it's going to be absorbed by Earth. But yeah, Earth would gain a ton of moons, as in asteroids, orbiting around the planet. If this were to happen in real life, let's just face it, all life would be dead. Oh yeah, another explosion. It just got super bright here. All the oceans are evaporating as the shockwave goes around the planet. think even the atmosphere is sort of going away, or it's just because it's so hot that the atmosphere is becoming plasma. That's probably it. So, yeah. The Amazon rainforest destroyed, and soon the eastern seaboard of the United States. So all this, most of it is gonna come back to Earth and just slam onto the surface, but some of it might even orbit around the planet, creating a bunch of tiny moons. And likely a ring, kind of like Saturn. Yeah, it's kind of interesting. This isn't slow motion or anything. This is 1 second per second, so they're live. And so this would, the moon would likely be absorbed into Earth faster than this, but maybe I'm wrong. I'm not sure. But yeah, it's getting a bunch of mass. Probably not enough to affect the gravity or anything, but it's gonna gain some mass. Yeah, as you can see, the seaboard's now getting destroyed. All the water's evaporating around it. I'm gonna go ahead and fast forward this. That's about 8 times speed. 8 seconds per second. So yeah, now the planet is fully absorbed into the planet. The moon is fully absorbed into the planet. Okay, this is 1.5 minutes per second. So that's pretty much the full extent of the fireball. Yeah, so now all the asteroids that were ejected into outer space are now coming down, hitting the planet, further warming it up and also creating new craters. And killing more life. Some of these objects are probably even bigger than the planet that killed all the dinosaurs. Asteroid that killed all the dinosaurs. Most of the material is probably simply just dust. So yeah. Let's see this object. 150 kilometers. 207. 125. Yeah, pretty much it's gonna eject probably hundreds of objects that are bigger than the KT asteroid. And so this caused a huge tsunami that pretty much ravaged the southeast and pretty much just the entire eastern United States. And so more materials getting from the Earth ejected. And there's all this dust here. Of course, as you can see, all these objects. Now the inner solar system might go into chaos since there's so much objects everywhere. So this is after everything cools. You can see there's a big crater and then the wall of stuff where it sort of, so when the asteroid impacts or when anything impacts, it creates a layer of material around the crater and that's what you can see there. So that patch must be a bit higher than the ocean. Which, speaking of, there's a new ocean around in where the Atlantic was. Now, Earth would probably take millions of years to recover from this. All the material would cause the Earth to go probably into an ice age that would ravage Earth and make it probably a good 20 degrees below its average temperature now. Now, as you see, it cools down. What is that? 23 degrees? Yeah, I guess I can consider that an ice age. But this game doesn't really simulate ice ages or anything like that much better than, or I mean, doesn't do it well in general. I wonder what this did to the rotation of the Earth. So it made the rotation a half hour less, which, I mean, over time that would be a big impact on what life that survived, but I don't think anything can survive a moon impact. So as you can see, there's a few new lakes in some of the continents. There's that one, a few of them. Yeah, that was, this right here was literally South America destroyed. And also this is a big long island with some lakes. There's one right here that used to be a lake, like in real life there used to be a lake right there, but people drained it for cotton farming. That's the Sultan Sea, another lake, new lake. Yeah, that's pretty much it for that. Now I'm gonna see what happens if you do Mars, which is about twice the size of the moon. This time I'm not gonna waste time showing it in live time. I'm just gonna do it. Oh no, didn't mean to do another one. Whatever. Holy crap. Yeah, and so this has even bigger objects. Probably a good size of what the moon is. This fragment is as big as Mars. Wait, let's see. Huh. Yeah, so all these objects, it's pretty cool watching them. Geez, the entire Earth is now like it was 4 billion years ago. It's safe to say that everything's dead. And so over time these objects, wait, I'm gonna focus on the sun. All these objects right here, as you can see, it becomes an asteroid belt. And they're all not really exact orbit around they all have unique orbits. And wow, this looks like a totally different planet. And it's spinning on its side, which might cause some strange temperature. Man, that's trippy. Alright, let's see what happens if we totally lock the planet. This video is like 25 minutes long. I'll probably end it after this. So this could happen if a planet is super close to an object with big gravity, kind of like the sun or something. In totality locking, that sort of means that the planet doesn't rotate and it's one side is constantly facing its star. So if we do this, now it takes 12 months to rotate and 12 months to orbit, so this side will constantly be dark, this side won't. And there'll be a small habitable thing in between the two. So yeah, the Himalayas are definitely gonna melt. Yeah, there they go. And so the whole planet sort of starts to become very hostile to life. A big ice sheet actually forms on the dark side. Yes, you can see there. Look at that. And then the pole would, or actually, let's see, we can zoom in here. So somehow the planet still changes, or kind of rotates barely though. So as you can see here, there's a habitable spot, mostly in Africa. And of course there's a water supply, which is the ice. Now what really fascinates me is how when you make the rotation normal again, I'm going to slow this down, all the ice slowly starts to melt. And then each of the sides equalize. This may take like a year or so, but over time each side starts to warm up. Or I mean, one side cools, one warms, making it equal once again. Well, I guess since there's so much ice, it's reflecting so much light, which is cooling the planet. Let's see, it's like 17 degrees, not much better. You can see some meltage, especially in the Gulf here, you can see. And the temperature is slowly rising. All the ice starts to melt. And so, entirely locking the planet also locks the, or I mean makes the tilt. There is no tilt now, so basically there's no seasons. Wherever you are, whatever it feels like, that's what it'll feel like forever. Yeah, this is a cool game. I'm gonna do more videos on it, so I'll see you guys in the next video. Peace out.